Hey children, welcome to Station 8. If you've made it through all the stations, then I'm more than sure that you will be fairly successful on your end of module exam, which is going to be on Friday. So what we're talking about in this station is actually comparing linear equations to exponential equations or relationships. And so the past couple of stations you've been working heavily on exponential relationships, and now we're going to take a look at the two different kinds and how do we determine which one is which and what that means for the relationship. So again, a reminder, the general exponential form looks like this. We're multiplying by a growth factor, which is taken to a power, and then the linear form is y equals mx plus b, where b is where we start, or our beginning value, and m is the slope, how much we change by each time. So we're going to look at these two by going through an example, and after we go through this example, you'll have a very similar but different example to go through on your own to kind of practice identifying which is which and how can you tell. So if we come here, it says Miss Rico bought a mint plant that had 5 leaves at the beginning of the month. 1 month later, the number of leaves on her mint plant had doubled. Her mint plant continued to grow in this same manner. So which manner are they talking about when they say this same manner? Well, it says that 1 month later, the number of her mint leaves had doubled. So that means it's going to continue to double. Okay? Double is a really interesting word because it's loaded with a lot of connotation, which means it means more than just what it's saying. Doubled actually means times 2. That's what doubled means. So this is our first indicator that maybe this is not a linear relationship, because in a linear relationship we don't multiply by something over and over again. Instead, we add something over and over again. Whereas if we look here, this is multiplying over and over. And if you're like, no, Ms. Rico, we only multiply once. No, the exponent is what makes it happen over and over. Okay, so that's one reason I think this is actually the exponential one. And then we look at the next problem over just to kind of examine that one. It says Ms. Barrow bought a strawberry plant. The table shows the number of berries B after n months have passed. So this looks like when she bought the plant, she had 8 berries on her plant, and then after 1 month, she now had 14 berries. So I can't think of a number that'll multiply easily to make 14, so let me check if this is maybe addition, which it might be. So if I look at this, I can add 6 here, and let's see if I can add 6 to 14 and get 20. Yep, 14 plus 6 is 20, and 20 plus 6 is 26, so that's great. So here's what we call a constant rate. It's constant because it's changing by the same amount each time. Constant rate, I'm adding the same amount each time. I'm adding, and if you're saying, oh, Miss Rico, but we're only adding once there, no. The variable here is what makes us add over and over and over again. So this is adding over and over. Okay, so now I've decided, and I've kind of lined it up there for you, that this is a linear relationship, and the one over here is actually our exponential relationship. So we're going to examine what do those two look like different than each other. And the first thing we're going to do is decide, it says decide which relationship is linear and which one is exponential, and give your explanation in a complete sentence. So that's what we're going to do first. I'm going to come here, I'm going to say this is an exponential relationship because the leaves are doubling each month. And then I'll go over here and I'll say, well, let me give you a second to write that down, I guess. It'd probably be more nice of me. I'll come over here and I'll say this is a linear relationship because the number of berries is increasing, that's a G, at a constant rate each month. So each month it increases by 6. That's the same. It's never going to change. Whereas if I look at how many it changes by this month, it just depends on what month it is because it doubles what it had before. So it says create a function to model Ms. Rico's mint growth where M of n is the number of mint leaves at the beginning of each month and n is the number of months. So they're telling me that M of n is what my function is called. And we kind of already know that n is the number of months, and we know what A was. She started with 5 mint leaves, and we know what B was because they said the word doubled, which I already explained means times 2. So this means I started with 5, that's my initial value, and then each month it doubled. And the month, the variable here is n. Remember, we have an exponential variable. And if you check this format with our format for our equation up at the top, you'll see it's the same. A times a B times x. So where A and B are just numbers. So a number times a number to the variable power. So this is our equation for how many mint leaves are on my plant. Now if we look at Ms. Barrow's equation, it's going to be a little bit different because it's linear. It looks like this. It does not look like this. Okay? These are two different types of relationships, so we have to describe them in two different ways. So, but it's still just as, we can still use all the information we already got here. So remember, our y-intercept happens when x is 0, so in our case n is 0. So how many berries did she begin with? She began with 8 berries. Okay, and what was our constant rate? Our constant rate was 6. So if we know b and m, we can write our equation because it has to be in mx plus b form anyways. So we can write y equals 6x plus 8. All I've done is plug in b is 8, so I put the 8 there, m is 6, so I put the 6 there. Okay. The last thing it wants us to do is it wants us to use a graph to estimate the number of months that will have passed when the number of leaves and the number of berries will be the same. So they want to know when we're going to have the same amount of berries and leaves. So to make this graph, I'm actually going to make this bottom part my x-axis and this line going up and down my y-axis. So I start with 5 mint leaves. So let's say right there. So at 0 months I have 5 mint leaves, and they tell me that each month it doubles. So if this is 1 month, what's double 5? Double of 5 is 10, so now I have 10. And if this is 2 months, what's double of 10? Double of 10 is 20, which is here. So that's pretty much the only space I have for my graph, and it should kind of look like a little bit of a loopy, like that. Mine's not perfect. Yours won't be perfect either. That's okay. And then let's take a look at what Ms. Barrow's berries would look like. So she starts with 8 berries. So I'm going to put a point at 8 because that's 8 berries. And then it goes up by 6 every time. So after 1 month, she's going to have 6 more, which is 14 berries. And then after 2 months, she'll have 4 more, which is 20 berries. So this actually makes it very easy for us to estimate. And I guess I could have drawn my graph by making the space a little bit bigger, but this still works out. I can easily see now where they're going to be the same. They're going to be the same where they cross. Well, even though my graph is not very good, but I drew my point so I can see this is where they cross, this is where they have the same. And this seems to happen, if I look down at when it's happening, this seems to happen at 2, what does this represent? 2 months. So the number of leaves and berries are equal at 2 months. And then it says, use graphs or tables to explain why mint leaves will eventually exceed the number of berries, even though there are more berries to begin with. So we just used a graph and I didn't leave enough space, so I'm actually going to use a table to compare it. So let's say we have n months, and we have mint leaves, and we have berries. So in the 0 month, I know Miss Rico started with 5 mint leaves, but Miss Barrow started with 8 berries. And I know Miss Rico's is doubling and Miss Barrow's is adding by 6. So in 1 month, double times 2 is 10, and plus 6 is 14. And 2 times 2 is 20, and plus 6 is 20. So here's where they were equal to each other, if you remember from the graph. 3 months times 2 gives me 40. And then plus 6 gives me 26. And if I went 1 more month, times 2 would be 80 leaves, but plus 6 would only be 32. So here you can see which one is going to exceed the other one. So exceed means to pass it, to get bigger than it. So we can see the mint leaves, they exceeded the growth of the berries. So there are way more mint leaves than there are berries, and there's a reason for this as well. And the reason is, if you look here, all of these I'm multiplying by 2, right? So here, if I wanted to think of this as adding instead, this would be like, here I added 5, but here I added 10, but here I added 20, but here I added 40. So here it's like I'm adding more and more and more, but this one's always adding the same amount. And that's exactly why this one is exceeding this one. So I can actually put that into words, and I can say the mint leaves I can't get this to write properly right now. It's really bugging me. The mint leaves do not grow at a constant rate they grow faster each month. Because they are doubling. Okay, so if you look at the next page, you have a problem that you can do that is similar but different about how Miss Brooks bought gerbils, and I thought I fixed the spelling on that, but apparently it left it there. Gerbils, and Miss McFadden bought bunnies, and you can take a look at who had more pets at the end of their months, and determine which one is a linear relationship and which one is maybe an exponential relationship, and why do you think that? Go ahead, get this finished, and that is all. See ya!